So if you can record, because sometimes we go up beyond 9:30.
Yeah, okay, I've started host. I've started the recording. You can proceed now.
Cool. All
Oh.
right. So let's go with the first problem, the rotate array here. Given an array, rotate the array to the right by k steps. K will not be negative. And then in here, they try to have it in the O constant for the space, for the extra space. I guess for the extras, for the constant space, we can do it. The brute force way is pretty easy. We can just, I think first we need to simplify k first. Let me put here the algorithm, the basic algorithm. We can simplify k by mod the number of lengths. So no matter what, if it's 100, if the length is 2, we're still gonna have the same k. Simplify the k. And then the next one, if we use a brute force, then we can shift it to the right k times. We don't need to have an extra space with the brute force. Shift to the right k times. However, there is another trick that we can use to solve this instead of brute force. This is by reversing the elements. So let's say for this example in the array here, if we reverse, so first we reverse the whole array, then it's gonna be 6, 7, 5, 4, 3, 2, 1, and then you can divide it into 2. From 0 to reverse 0 to k minus 1. So in here, if our k is 3 for this example, then we can reverse from 0 to 2, which is going to be 5, 6, and 7. And then the last one, we can reverse from k to the length minus 1. This will give us 1, 2, 3, 4. And then we can use the same array. We don't need to create a new array here. And we will get the result the same with how many rotation we can do for k amount of times. So I will implement the code here. The first thing that I'm going to do is to simplify the k. And once we simplify the k, then we can have a helper method here to reverse the array. Let's call it start index and end index. The condition will be as long as start is not greater than the end or equal, then we can do a simple swap here. Will be temp. So this one, in this case, we will have our reverse, but let's not forget to increment the start index and then decrement the end index. And then in here, we can do our second part of the algorithm to reverse it 3 times. So first we reverse the whole thing from 0 to the end. And then we can reverse the from 0 to k minus 1. And then lastly, we reverse from k to length minus 1. And I think this is it. Let's see. Hopefully I don't have, oops, there's a bug here. Integer k, okay, just use, oh, we don't need to specify integer anymore. We just need to simplify the k, that's right. And there you go. This is the solution. I like this solution because it's simple. It's easy to remember, easy to follow through. Let's see. Performance-wise, I think the memory is not great, but the time-wise is pretty is fast enough. Is there any feedback or comments with the solution?
Oh, this is a great solution, yeah. And actually you implemented on the fly. That was great.
Well, I did it already yesterday, but it's just
Oh,
a
that's
review.
fine.
Yeah,
That's fine.
it
Yeah.
is just a review. Yeah, but this is the I like how the reverse methodology. Yeah.
Mhm.
Yeah, and that line 12 can come also after 13, 14. It won't make any difference. Like you can first reverse k elements, then remaining length minus k, and then reverse the entire array.
Sorry, you're saying that the line 12 can be done?
I mean, I'm telling you first reverse the entire array, right?
Yeah, I first reverse the entire array, correct?
So you can, I mean, this perfect, but just other alternative. It's not an alternative. Just I'm saying you can reverse first k elements, and then rest will be length minus k that you reverse, and then reverse the entire array. I'm just saying
Okay,
13.
okay, got it. So you swap the 14, 15, do it first, and then do the reverse the
That won't
entire
make
array
any
later.
difference.
Yeah, I think so. I think if we want to talk about the time complexity, I think at most we are iterating it twice, right? Because at first we reverse the whole array, and then the second one we reverse from 0 to k or k minus 1, and then the third one is from k to like minus 1. So to be very specific, it's O to n for the time complexity.
Yep.
Yeah.
So you were talking about brute force approach, right? So in the brute force, you were saying like it would be almost O of n multiplied by something k.
Yeah, it's brute force is gonna be O n times k, right? Because we need to rotate it k times. I think we will. It could have some impact if the array is very long and then the k is this is the k is like the maximum number of length.
Yeah.
Or length minus 1.
Yeah.
I think one small optimization, like if length of the array and k are equal, then you need to return the array same. I mean, you don't need to rotate, right?
Yeah.
It will be
So
same only.
so if k equal to nums length, then we can just return right
Return
here.
array.
This is gonna save the operation.
Yeah. So there's another approach. What they say is about like using some extra space, So
Yeah.
in that case, also you are actually doing it with O of n and just using an extra space about maybe same like O of n.
Correct.
Right? Just use another array and do that. So that is also one good option, when in an interview you are not able to remember this. I know this is a very good one and it's very nice you brought it up.
Yeah.
If you don't remember, at least that could be one way to do, and that is not still a brute force, right? It will still work. Yeah. So
actually,
go ahead.
Actually, my first intuition when I tried to do this solution yesterday, my first intuition is to still using the constant space, but kind of like swap it. So it's like a running array. So let's say if k is if the k is 3 here, so we go from here, we know here, and then we swap it with 1, and then remember the 4, and then put it somewhere else. But that one, I found it difficult to follow the pointer. But that one we can also achieve it in the constant space, and then same with O of n as well. Yeah. But I just like this one better. It's easier to memorize if in case we have this problem in the interview.
Yeah.
All right.
For just a point, we are rotating the array from the right side in this case. What if we rotate the array from left side?
Oh, that's a good question. So in here, we can only rotate it like to the right? If I'm wondering if we rotate it to the left, whether we can use the same formula or not.
I don't think so. Well,
length minus k will.
In such case, I think we should remember this thing also, that we are rotating from the right or left. For this trick also, I'm saying that.
Yeah.
Okay.
So,
I
but
think
do you have any, I think, who was talking just now or what?
Yeah,
Yeah.
this was location, but I don't have
Yeah.
anything just now. It was
Okay,
just
okay,
a
no
point
problem.
which came in my mind. Yeah.
Absolutely, yeah. That's a good thing to actually discuss. But if you have some tricks, just try to, present whatever it is. Yeah, it's
Sure,
good.
sure.
So in that case, K will be changed.
no, you can do length minus k to the left side if you have to solve this one using left.
Yep.
Yeah.
So, come again, Shashank.
They are telling that we have to rotate by k times. Let's say I have to do it in a left approach, then length minus k, that you rotate in the left direction. And
Okay.
again,
Yeah,
yeah,
just change your
counting
K
this,
to
yeah,
length minus K.
Wow.
exactly.
Okay, that's
Yeah.
Yeah.
cool.
Yeah.
Yeah. All right. Should we go to the next solution, or we are?
Yeah, yeah. One thing, I just want to tell you. Can you increase the font size? Because
Oh,
that's
Yeah,
slightly
that's
not visible for me. Maybe my screen is
I
not so
am
good.
no,
sorry.
no.
Let's see.
And try to fit it to the entire screen.
Okay.
That what
Whoa,
is
Yeah.
is this better?
Yeah, this is better. Yeah, absolutely.
Okay, cool.
Yeah.
All right, let's go to the next problem. So I also did this already yesterday, but hopefully, I can share. I can try to learn how to articulate it as well. But again, this is a variation of the island counting. But the variation is if we have surrounding x, then the 0 will be x. But then if we have the border, then this will not be infected. I will name it infected. So for everything that is surrounded by x, it will be infected. Otherwise, for the one in the border, is gonna stay as it is. Again, this is the trick for this problem is we need to use give me a second here. We need to use the island counting, but then the twist is we should start from the border. So let me give you an example here. For the
So when you are
example,
saying, sorry to interrupt you.
yeah,
So when you
don't
are
worry.
saying island counting, do you mean to say use a DFS way, right? The DFS traversal.
Yeah, I'm using this because I use the stack usually instead of the queue, but I think it's the
Okay.
same anyway since we're gonna exhaust. We need to exhaust in each iteration. We need to exhaust the stack or the queue, right? So it doesn't matter if it's a stack or a queue. But yeah, actually it's. I think mine is a BFS, the BFS way.
Okay. Let's see.
But
Yeah.
we'll see. In this case here, right, we need to start from the border, and then in this case, the border will be this element here, and then we need to start infecting it. So we can change it to, because this is a character, we can just change it to B here, right? And then basically whatever that is inside the one that is not touched the border, we can leave it as it is. And then at the end of the operation, then we can run through again the 2-dimension array. And then if it's a big O, then we change it to X. And then if it's a B, it's change it to O. So again, I find this trick is gonna be easy for me to remember during the interview. But yeah, that is the trick here. If we implement that, then it should give us the solution that we want here. So let's try to implement it here with any of the 2D array problem. It's helpful to make it tidy, to have a static class of point. And then I'll name it row and column, R and C for the property. And then let's create the constructor. And then now, I think it will be handy to just collect the, we can save some operation. this can only apply for board that is larger than 2 by 2, either or. So if I have so if the board length is smaller or equal than 2, or the rows of the column size is smaller or greater than 2, then we can just return here. This will save some operation. Next, we can do the the row size, which is going to be the board.length, and then the column size will be board, the first element, dot length here. And then maybe we can also instantiate the stack or the queue here. I'll just put stack because I usually use the stack. The stack should be a collection of points, and we can start iterating into the 2D matrix here. And then there's a multiple way how to do the, like, if we want to go to the top, bottom, left, and right, but I like this idea to put it into a 2-dimension array. So it's more tidy. It's gonna have less repetition.
Yeah.
And then I'll do it 4 times. Oops. And then first, let's handle the top. The top will have the row +1. The bottom will have -1 and 0. And then the right will become 0 and 1. And then the left is going to be 0, 0 and -1. So this is our 4 directions here. We'll have it handy later. So in our algorithm, we want to start with the border here. So we cannot just check anything that is big O. So we just do our if statement here. If R equal to 0, or column equal to or C equal to 0, or R equal to the row size -1, C equal to col size -1, then this is gonna cover the border, and then we can just wrap the whole the OR condition, and then put the check the board element, or the point element. So with this if statement, this will make us start from the border that has a O, and then we start infect this the neighbor O. In here again, we can use the first we need to mark it to B. Market has visited. And then we can push it to the stack. This is where our helper class is handy here. And then now we can go through the stack while stack is not empty. And then we can try to check the neighbor. And in here, I will use the direction. Let's name it I. Integer I 0. Dot length, and then I++ here to iterate to all 4 directions. And then once we have this, then we can start counting the neighbor. I will name it neighbor R.
Question: do you want to
Yes.
keep the while loop with the stack is empty outside of the for loop?
I believe so, because we need to we need to check in each stack. So if you have a stack here, your stack is gonna be, for this case, is gonna be what here? 3, 3, 1, right? The point is 3, 1, right? And then it will start from here, 3, 1. And then from there, we will start to check the 4 direction here. And then when you go to the next one, once we pop it, and then we still need to go to the 4 direction. Does it make sense? Or do you think that the for loop, the direction can be outside the while loop here?
No, I was saying if the while loop should be, the while itself should be out of the for loop, the for int row and
yeah.
int
So
column.
the direction for loop should be outside the while, right?
No, I meant the for loop, the while loop at 24. Should it
So
be
like,
outside the for loop of line number 19?
oh. No, because we need to iterate through the 2-dimensional array. And then while we're iterating it, then we need to do this stack here, exhausting the stack.
Okay, please continue.
Yeah. So in here, we can pop the array, the stack. This will give us the current point, and then we can find the neighbor row and neighbor column here. My neighbor row will be current point R plus directions I, which is the first element. And then my neighbor column will be this one here. Then we can cover the all of the neighbor column, and then now we need to start looking whether they are 0 or not, or O or not. So if NR is greater than equal than 0, and NC is greater than equal than 0, this is row size, and then lastly, board and R and C equal to O. Then here we want to do the same thing here with line 22 and 23. We mark it as visited.
Should it be R? Because you.
Oh yeah, NR and it's supposed to be NR and NC.
No. The AND condition, it should be R, right? And
the AND condition. This one.
In the if there is 2 ANDs, right? The AND your
line 30.
No, this should be AND. That is correct, I think, right?
Yeah, we want to check the neighboring.
But then can this condition be ever true? Like oh yeah, I think yeah. Okay, I got it. Yeah.
Oh.
I think this is the beauty of using this direction. Is yeah, we don't need to have a for if statement, so we can combine all of them together, and then here we can push again to our array. Sorry, to our stack.
Yeah.
So this should give us the whole operation to go through the 2D array, and then in fact the border, the 0, starting from the border that has 0 and then going to the neighbors, and then once we go out of the iteration, then we go next again and to do the last one. If it's B, we change it to O, and then if it's O, we change it to X.
Yep.
And then in here, we can just use the if statement. If board R and C equal to Oh, then we will change it to X. And then if it's B, we change it to O. Oh, and it has to be else if. Because it's else if, I think the order will not matter which one that goes first, which if statement that goes first. And then that's all. We don't need to return it since we are updating the array by itself. Let's see if I have a new bug. Find symbol of row size here. Yeah.
Can you just submit it?
Yep.
Awesome.
There you go. Yeah.
That's cool.
So you guys can see the way that I solve, the way how the solution that I choose, the solution that I study is always the one that is intuitive to be remembered.
So
yeah.
Indra,
Hey, yeah.
Some questions. So
Yeah.
at line 19 and 20, do you need to iterate the entire array?
Maybe we can just iterate only the border, right?
Because you have a condition, if condition. You're only going inside if you are on
That's
a border.
right. Yeah. So in this case, we can modify the only iterate to the border, right? I guess my question is, how can we translate it into a code from that for loop if we only want to go to the? So maybe only for R0 and R equal to row size -1, right?
So basically,
so only the head and then the.
You need to split that two loops, inside loops into two loops. One will only go border.
Yeah.
Maybe 4 loops might be. You go left, top, left, bottom, like in some way, then you might end up doing 4 loops. Like 4 separate loops, what I'm trying to say.
No, I think we don't need to, Asif. If we can just do an if statement here, right?
Oh.
If R
not
equal 0, or R not equal to row size, then we can just continue, right?
Continue, okay.
Same thing with here, but we change it with C.
I think another way to do it is instead of increment the R, right? We just increment the interval. So like the first loop going to first row, the second one it jump to the last row.
Got it,
right?
got it. So from in this case, so R will be, so instead of R plus plus, we can just do it R plus row size, right? -1.
Yeah, that looks right.
Yeah. I'm not sure if we can do this in Java. Can we do this in Java, like in this for loop? This is, yeah. Let's give it a try.
Yeah.
And then, oops, in here we can do C plus minus call size -1, and then we don't need to have this anymore. And then let's see. Oh, it's wrong answer. So it could be. So R is 0, row size
1 at that time, right? Okay.
So I'm wondering why this will not work here with our answer.
Because you are means on line number 21, it should be C++ only, not C plus equals to column size -1.
Oh, for the column?
Yeah, yeah.
I think for the column, we also want to have the border too, right?
Actually, you are just taking the border cells, not the complete border. You are taking 0, 0, and means top left, bottom right, and top right, bottom left. Like that, it will calculate otherwise.
So in here, when we have from row is equals to 0, which is this, we're only checking this guy and this guy, right? Or I see for the column, we still need to go through 1, 2, 3, like the whole thing, yeah.
Complete columns.
Got it.
But then same with the row also, right? If we are choosing the 0th column, then we still have to go with from the row.
Yeah.
No, but in here we can. Oh, I see. So I guess we cannot use this then. We cannot use this shortcut.
No,
Maybe
I
the
think
statement will be.
I think that's a step size. So you need to have plus plus, which is right. But what you can do probably is initialize r equal to 1. That way we jump the row, first row directly. And row size could be r less than row size minus 1 would solve that. So in that case, we don't go into first row and last row.
Yeah. Well, but we want to start with the first and last row though. We don't want to check the O in the middle. We actually don't care the one in the middle. We always want to start from the border. This is why I think the idea is to start from the first element to the last element. I think the question is if can we jump forward or not.
We have two for loop. We have two for loop here, right? So you know, instead of to have two nested for loop, we have two for loop. You know, outside one after the other.
Yeah.
Maybe
maybe the easier way is to do the filter here, that if r is equal 1 to row size minus 1, then continue. Same thing with the C. Then we will always iterating through the borders.
No, but what is the complexity of that time? It is still going into two loops.
Yeah.
Again, n square. So the idea is to reduce like the n square thing to some.
I see.
So if you're just going through borders, then it won't be n square. That's what like.
Okay. So the idea is you go to the row 0, and then you go to the row 3, right?
Yeah,
and then the next one go to the row 1 with column 0, right?
No, you just want column 1 and column last, first column and last column, like column 0 and column
3.
Yeah.
Column 3 here.
So if you put the logic in the function from that if condition, then maybe we can split that for loop. And
yeah.
So first, like it's better like from line 29, it should be in a separate function. So that we run anytime from anywhere, like given a starting point, I can do, so basically Indra, this is not BFS, this is actually DFS.
DFS, yeah.
DFS?
Yeah, if you replace stack with the queue, then it will become a BFS. That's a different thing. But here, if you put that part in a different function, then you can call it from any different loops, and then it will be also easy to read.
I see. Cool. So in here with this method, the time complexity will be still OM, right? Like we are.
Yeah.
We need to go through. To each grid, the one that has the border. We need to infect the way that we infected. So the worst case scenario, we need to infect everything. It's ON.
It will be n square, yeah. OM into n.
Is it ON square or ON? I thought that the way that we see it, as long as we know the constant amount of size, that is gonna be an ON.
But like 44, you have two nested for loop, right?
Yeah.
So it has to be n square.
So
Yeah,
So
44, line 44. We have to go walk through each cell
row,
in a matrix.
yeah, cell.
But I think he's saying n means number of cells.
number of cells.
and it's number of cells here.
Yeah, but we have n by n, so that n square.
No, that is
rows and
columns, right?
So how, Indra, you will say like how many cells are there in the matrix?
So in here, for our example, we have 16 cells, right?
Yeah. So we say
we have
row
16
into
points.
column. We say row into column.
Yeah.
Row times column, right?
So I'm just trying to say that in interview, people would expect in this terminology order of row into column, and where your number of cells is are row into column.
I'm sorry, can you repeat?
So what I'm saying, like if you say in the interview, people, how everybody thinks is like in terms of row into column, the complexity.
Row into column.
Yeah. So if you say order of n, then it's as good as row into columns.
Yeah.
Because I don't know how many cells are there in the matrix, but I know there are n number of columns or m number of rows and n number of columns, and total cells are m into n.
Yep. So for this kind of question, right? Like what is the correct answer then for the time complexity? Is it O(n) square or O(n)?
O(n) square should be good because you have to visit all the cells.
Yeah, you have to, right? Yeah.
Yeah.
And your number of cells is n square.
Yep. So O(n), yeah.
But here, because of line number 29, the while loop, don't you think the complexity is going beyond n square? Because it is for inside a for, then a while. And inside that, there is a constant for. So that is only 4 directions. So I disregard that one. At line 31, I ignore that one because that is just 4 times. But but the line number 29, that is on top of the n square already of 23 and 24.
No, but he is not visiting. So he has a check at line 26. He will only inside if he has seen that for the first time.
Yes, because we do not blindly put it into the stack, but we only put it to the stack the one that we haven't visited. Then it will not increase the time complexity.
But don't you think the while loop is unnecessary here because you are only starting with the most recent B, the visited one at line 27? Would they? I'm wondering if there is a possibility that the stack will ever have more than one element.
It could be. Let's say if the case is like this, right? If we do it like, so we will start from here, right? This is gonna be B, and then we put B here, or for example, and then we have this one here. Then when you go through here, we're gonna put this to the stack, right? B, and then right and bottom, then we will put into the stack. So these two will be in the stack. And then you go, let's say you put this one first in the stack. My stack will be, what is this? This is 1 and 3 now. And then the second one is 3 and 1. See, this is 2 in the stack here. We have 2 elements in the stack.
But how do you put the 1, 1 into, how could you put that as B without using the stack? So,
so in here, so we start from here, right? So
yeah,
we start from the border, right? Because in here, our if statement here will always start it from the border, right? So this is going to be the first one here.
Correct.
And then once we put this into the stack, in the beginning, we put 1 and 0 to the stack, right? And then we go to the for loop, stack is not empty, then we pop it up. So 1,
I
0.
understand that part.
Yeah.
My question was, can you please show a situation where the stack will have more than one entry?
Yeah, so after this, once we work on here 1, 0, then we will check the neighbor of 1, 0, right? If the neighbor of 1, 0 is, it will run into this if statement here. If the neighbor of 1, 0 is 0,
I see.
Yeah, then we will have 2 entries in the stack.
Got it. Thank you.
Yeah.
Okay, sorry, Indrang, that was, I think this is BFS only, but using stack.
Yeah, this is DFS actually. This is DFS because you pull out something from the stack and then depending on the condition, put one or more neighbors onto stack, and then you iterate over them and go.
So in
maybe
easy if you replace this stack with the queue.
Yes, I think that will be consistent, right? Because the BFS will always, in the general guideline, the BFS is using queue, right? So it's make it less confused.
No, but this is DFS, right? You are using stack, correct?
No, actually, so here, if we change it to queue, then it will gonna be the same here.
Right. But the earlier one, when you were using stack, so whenever you are popping one, you are actually popping the last one, right?
So, but he's putting next.
Oh, okay. Then he's
yeah.
So either way, it's catching the ear from left or right.
Correct.
It's the same thing. Okay, good.
Yeah.
Sorry, that confused you.
Oh, no worry. I think I'm also thinking, like since this is actually a BFS, then maybe it's better to use queue to make it more consistent, right?
Yes.
BFS like I saw it in the internet the way that we remember it. BFS is barbecue using queue.
Wow.
It's a tip. And then I think the poll. No, this is supposed to be poll. And if we run it, yeah, it's still gonna be the same. All right, should we move on to the next solution, or somebody wants to take it over? I only have like 15 minutes left.
No problem. So, Shajan, are you?
Yeah, if he wants to take it, I mean, otherwise I will.
Yeah, sure. Yeah, I think it's just 15 minutes to go. So maybe.
Yeah. So I'll just stop my sharing.
Sure.
Yeah, sure.
Thank you, Indra. Thank you very much.
Yeah, thank you.
Oh, you're welcome.
Yeah.
There was this like grumpy bookstore owner. We are given a bookstore owner is there who has a store open for customers.length minutes. And every minute, some of the customers enter the store, and all those customers leave after the end of that minute. On some of the minutes, the bookstore owner is grumpy, and if the owner is grumpy on the ith minute, the bit will be set to 1 at that particular index. Otherwise, it will be 0. Now, when the bookstore is owner, the customers of that minute are not satisfied. Otherwise, they are satisfied. So you need to know the bookstore knows a secret technique to keep themselves not grumpy for X minutes straight, but can be used only once. So we need to return the number of customers that can be satisfied. So if we look at this example, so for the last 3 minutes, they are using straight as 571 and corresponding to this is 0. So customer is satisfied at this point. And again, this, and that those 3 ones we are using, which sums up to 16. And your length, customers.length is equal to grumpy's.length, which will be less than this. And yeah, so any queries in the question or anything like that?
Yeah, so the question looks
bit clumsy.
Yeah, it's very no tricks in it. It looks very straightforward, right?
Yeah.
And the customer length and grumpy length array, they both have the same length. That is also what is specified, right?
Yeah. Each time he opens the shops, his mood depends whether he is angry or in a happy mood.
Yeah. So whenever it's 0, we need to take that. If the grumpy element is 0, we just should take that value of the customer. Correct?
Yeah.
Okay.
But he have this technique of using X minutes straight. Like for 3 minutes, he can make himself cool. Like
So whenever we have that value X,
yeah,
so whatever the values are during that time, we can even take the values for 1.
yeah, override the values. Yeah,
Yeah.
exactly.
So the value of 1 also can be added
Because
to that.
he's not happy at 5. He's 1, right? But he used the last trick that for 3 minutes from here he'll be happy with the customer, so the customer gets satisfied, so he can straightly use these values. He'll ignore this one in that case, else he'll using the normal.
So I think the what do you say, sliding window technique can be used over here, right? So initially what can be done is like find a sum of all the values of the customer for the non-grumpy one, like when it is 0, keep a sum for that, and then you do an additional sum for X, start for the first X values in the customer. So you add whatever you get with that. If it's what do you say, the value of grumpy is 1, you add those for that X, and then after that X you start the sliding window. So in the sliding window you are keeping the window size as X always, So whenever you move that X all over the customer array, and you try to actually
you have to be
remove the
greedy.
values, right? Yeah.
Yeah.
And find the maximum value in that range, and then add to the earlier sum what we calculated. Correct.
I think the first run we can filter out the one that is already satisfied, right? So that is going to be the first run. Filter out the one is already satisfied, count them, put it into the satisfied count, and then we can try to use this technique, the special technique. But then the special technique cannot be used to the one that is already satisfied.
Yeah, but when we have the value of satisfied one, when we run through the area again for the non-satisfied one only, we won't run for the satisfied one, right? So in the non-satisfied one, we'll look only for the case for the size of X.
Yeah.
So whatever the maximum, we just take that and then add to the satisfied value, right?
Yep.
Yeah.
So I think also we should go with the sliding window technique for first, and then we'll traverse the whole array. For in one go, we'll calculate the how much the maximum number of customers we can satisfy, like for X window.
Okay.
And then in second go, we'll go just simply traverse, and through the grumpy array we will calculate.
Yeah.
So you're saying you do it in the one iteration only, right?
No, there will be two iterations, but I'm saying that firstly we'll calculate the X part. Like first we'll run the sliding window just to calculate the X values, like maximum X which we can have.
Okay.
And then we'll go.
Yeah.
You want to share code, something like that?
No, not as of now.
Okay.
So what is your approach, Shashank?
Yeah, same like I'll first in speaker I didn't remember. I first calculated the satisfied. Who all are satisfied. I'm adding their the value corresponding to them I'm adding, and in the second pass I'm just checking if that is exceeding your window size. That particular if the index bit is increasing your window size, you just whatever. This is like the one which are not satisfied, okay, and this is the one which are satisfied. Corresponding to 1 we have this, and corresponding to 0 we have this result. And whenever I see that that particular index that is exceeding your window size, and second is like from that particular ith index minus, you do 3 back, you go. in a window size of 3 back, and if that shows equal to 1, just to subtract it from that sum and take a max of it. Yeah.
So you're using the single iteration?
We have one this single iteration and then just taking them. At every step, I'm checking if that current index is greater than the window size. Then I'll go back 3 steps back and we'll check at that value if that is one. I mean, at that point, the customer is unsatisfied. Then I need to subtract it from the this unsatisfied sum, whatever I've collected with.
Okay. Yeah, can you run through the test?
Yeah, sure.
That would be more clear.
Okay. Like, so first we'll calculate all the satisfied. So your satisfied will be like every time you hit 0. So I'll have to take this also, grumpy one. Yeah, it's correct. So whenever you find that grumpy is 0, that means customer is satisfied at that point. You just club. So you can add 1 and then another one. This one you can add, and this one also you can add. Then this you can add 5, right?
No, 7.
Oh, sorry, 7, because that there is it. So 7, if you add, what is this? 11, 10.
Right, yeah, it comes.
And yeah, and total sum, if you subtract this 10 or the other one you can take. Other one will be, this is 0 and 0 plus 2 is 2.
So that is for the
unsatisfied.
Unsatisfied, okay.
Yeah. So this is 3 and 3 plus 5 is 8.
Oh, okay.
Yeah. This is your 8. I think sum is correct, right? 5, 7, 12 to 14, 14 to 16, 16 to 18. Yeah, that's correct, right? And along with that, whenever you see, I mean, directly added, it shouldn't be added like that.
Yeah,
every time
you have to take only 3 values, right? So
3 values, yeah, I think
okay.
You have to keep the indices of that.
No problem. So the first current sum will be 0, 1, the 0 value, right? And
okay,
then the second will be 1.
The non-satisfied 1.
Yeah, and then another 1, and then okay. So then it will be 6 at the end, correct?
Yeah.
Okay,
Till
so
3,
10
I
plus
think
6.
we'll go first. I think from 4 this will start.
Okay.
Yeah.
So, but this looks a very straightforward problem, right?
Yeah.
If you know the sliding window, then this is very easy.
So what is happening in the if condition?
I think Ashwani is speaking. Voices.
What is happening in the if condition?
Yeah, if condition, like initially till this point, when you are at 2, till that point you do the normal one, like some all those who are satisfied and some who all are not satisfied, isn't it?
Yeah. Okay.
Yeah. You do once you hit once you come here, you find that you are exceeding your window size. Just then you need to subtract that that particular value at the index I minus x. From here 3 back you go and subtract it from your cursor, and this go on at last just to take the maximum whatever you have, and just add it to the satisfied. This technique, this one.
Okay. Yeah, this is slightly different, like than the string manipulation sliding window.
Yeah, exactly.
Yeah. But you have done this in a very concise way, so it's slightly it's difficult to implement, but I did the very normal way, it has more code. So the way I was describing, I did like I used 3 for loops.
Okay.
One was for the calculating the satisfied.
Yeah.
And you want to share, Santosh?
Yeah, share it, I think.
Yeah, I can share that.
Okay.
So I did it this way.
Okay.
So I use default sum. So in the default sum, I'm actually taking this customer array,
Okay.
and then I'm just subtracting the grumpy value
Complement, yeah.
from minus. Yeah, I'm taking the complement.
Mm.
So I just get the default sum, and here actually I start the sliding window. So from line 10, I actually start the sliding window. So the first one, I calculate the first x value. So the current addition will have the first x, when the grumpy value is 1. Okay.
Okay. Mm.
And then I actually take the max addition. So I just first initialize with the current addition because that is going to be the same. And then I start iterating from x in the second for loop to the end of customer size. And then every time the same thing what you explained, I use the current addition, and then actually I subtract the previous value of I minus x,
Yeah.
okay, and then add the new one, right?
Mm.
So this is the sliding window here.
Yeah.
And then the max addition is nothing. I just see the maximum of the current addition value and whatever was the max addition earlier. Yeah. And then at the end, I add the default sum plus max addition.
The sixth line you are able to use 1 minus this because of 0 and 1 value, right? Otherwise it was not.
Yeah.
Mm.
Because that is what they satisfied. They have specified also in the notes.
Specified.
It's
Yeah.
going to be only 0 or 1.
Yeah. That's a nice one. Rather than putting into 2 lines, 1 line is enough.
Yeah, actually I used that only earlier, but then I found this somewhere, so I thought, okay, maybe use it.
Yeah, because I've seen this approach at many places. Wherever 0 binary, we are playing with binary 1 minus 0. You do both cases. You can consider in that case.
Yes.
Yeah.
So, but I have so much code, like actually 2 for loops. So 2 times I'm iterating through the customer array.
Yeah.
But in your case, you are doing it in only one. So that is an advantage there.
Santosh, your last 2 for loops are nothing but 1 for loop only, because you are going like 1 of n, right? Because you are going up to x and then from x to customer size.
Right. So I'm saying like I have the second for loop here for the sliding window and the first one for the default. So there are 2 for loops. Yeah.
For me, understanding your code is easier because this is how I have learned the sliding window.
Yeah.
Exactly.
This
Yeah.
is like a
I
standard
also
template.
understand that way. Yeah.
Yeah, standard template for the sliding window.
Right.
So that's
It's intuitive.
Yeah. But like when you become more advanced, then actually you write the way Shashank writes, so that is what.
Yeah.
Yeah. Okay. So that's what I had.
Yeah, this one I like, but this line, like I have made most use of it. This one at wherever I find binary and all.
Yeah.
Like 0, 1 return. Yeah.
That's easier to do it.
Yeah.
Okay.
Yeah. So regarding time complexity, so your
so it is like O of n, right?
Almost.
In both cases. Yeah.
Hmm.
And we don't have any space complexity, correct?
Yeah, extra space we are not taking any.
Yeah.
Hmm.
So I found this problem to be more easier than the one what Indira was solving for the grumpy one, right? Sorry, the surrounded regions.
The reasons, yeah.
Yeah, the region was slightly more complex, even though it was medium.
And yeah, and stack implementation of BFS is like he was using BFS only there using stack, right?
Mm-hmm.
Yeah, that I was tension like.
I think that marking with the B and then counting, that was the trick.
Mm-hmm.
Trick, yeah.
Yeah.
Because if you don't do that, then you'll have to use a visited array for it. Again, you are adding more.
That is where he's avoiding that visited by marking. Yeah.
Also visited, also not, but because he has to separate from the border,
And
whatever the border
insider.
cells and the insider one. So therefore, he has to use it, and so he had to use it for the visited also. So 2 in 1. Yeah. But that was a trick. So it's not easy to understand, I would say, that problem also, the way it's implemented.
And secondly, the way he represented time complexity by number of cells is the first time I have heard. Like, is that the way, like in matrix we represent by number of cells? This is the time complexity. I mean, although m into n will be equal to that only, but since he might have used in some interviews.
What else you can say? It's the same thing, right?
Yeah, it's so they'll say number of cells or order of m into n, like that.
Or maybe like Asim was saying, explicitly say it is O of rows and by columns. Something like that. And you can always say row by column is equal to number of cells. So if the number of cells is n, then it is O of n. Or if it is not, then it will be O of n square.
O n square, yeah. Yeah, but that's a nice, unique first time I heard, and so.
Yeah, me too. So I just wondered how it is, but anyway, you have to visit each and every cell in that. So there is no way.
Yeah.
So whether it is n square, it will still be accepted. Correct.
Yeah. Yeah. And the matrix will always be this square one only in that case. In such problems,
But still, I'm not sure why we call it n square.
By n into n rows and columns.
But n is your input size, right? And your input size is number of element. And it's up to you how you represent, how you actually provide your input. But actually, your input is n only.
Yeah, that is true. But that is what we are saying, But if the interviewer says, okay, we have n rows and n columns, and then if he says that is n.
So root n into root n, should somebody say? Like if n is the element, then root n into root n.
Then in that case, for this problem, it should be m cross n, because it's not given that number of rows will be same as number of column.
Yeah, it's not mentioned anything like that. That's true.
It's not, yeah.
But so it can be rectangular, do you think?
Why not?
Why not?
Yeah.
Okay.
So therefore, either number of cells is also not a problem. But if not, then we can always say O of columns by rows, right?
Rows, yeah.
Because the interviewer might want to say as explicit, be a more explicit.
Yeah, I would prefer to say that size of board.
Yeah.
Everything comes there. Yeah.
Number of cells. Yeah.
So any matrix problem it comes, it will be size of board. We don't need to look any for loop, anything while inside what we are doing. Because in every matrix you'll visit every matrix problem you'll visit the cell. Is it like that, or you can't generalize like this, right?
Yeah, I also agree there.
You can't.
But the whole thing started, the discussion started because he is using a DFS and BFS, right?
Yeah.
So in DFS, BFS, you tend to visit some cells more number of times if you are not using visited, something like that, correct?
Yeah, exactly.
So that is what the thing was coming up. So that made more sense, right?
Because within two for loops you are using while, let's say if that was taking also order of n, then you can't say board of size should be the time complexity in that case.
But even with all the if else cases, whatever he has done, implemented, it won't visit more than O of n square, or maybe O of the cell size. Size, yeah.
No, I'm saying it should not. It is, apart from this, had been the case like some other problem where while would have been taking order of n time. N times it might have been visiting something. So already he used two while for loop. Inside that he's using another while. So in that case, it won't be order of NQ, or should be order of board of size should be the time complexity.
Yeah. So it is again problem dependent.
Yeah, it's like. Yeah, it was very fast today's session.
So how did you do session?
It's the same like I have used. I'll show. So I just first marked all the boundaries with the E. This is just the. Let me. Wait. Yeah. Now it's visible. So what I did is like. I first went through every cell I went, and this is your what you say. Those border conditions, and I'm checking if it is O, then what I'll do, I'll just keep on this is where what you say DFS is occurring.
Yeah, DFS, right.
Yeah, so I'm replacing every O with X initial. If it is O, then I'll replace it X, and if you see it is E as E, then in the final you have to make it as O, like this one. because you can't do anything with this border one, right? I made every O replaced with E, but you can't do anything with this. So in such cases, you have to return back from E to O. So this is that portion.
So basically the same technique, right? Like
almost,
but the recursive solution.
Exactly. His was recursion. This also, yeah.
Yeah, yours is recursion.
Recursion only.
His was iterative. Yeah.
He was iterative. Yeah.
Iterative stack. Implicit, that external stack he was using. No, here implicit stack is being used.
Yep.
Yeah.
But where are you checking here? It must be 0. So you are directly putting it as a E. But okay, but you are calling that function only when you see the 0 on the column.
0. Oh, yeah. Oh, yeah.
Yeah. Okay, fine.
Yeah.
Yeah.
Yeah. You can. Some chat was there. You say, can someone share the third approach to rotate the array? Third approach is what, like?
He is saying about the one which actually
Indra did, right?
Flipping the cells, not the reverse way. Yeah, that's slightly complex. Have you done that approach? Because I was trying to understand.
No, I've done.
It is slightly trickier and it will take more time to understand. So I just left that. I just went the reverse way.
I think it's in Geeks for Geeks I have seen.
No, this guy is also in here also they have actually specified the elite code guys. So you have a solution for they have. That is what I think he's saying, using cyclic replacements. So the third approach is that.
Oh.
Yeah, I didn't understand that. Means it's not difficult to understand, but there are some
tweaks.
Yeah, I didn't go into the details. So he's asking anyone want to share that. Maybe if you can, someone can write a code and then share it in the Slack.
That will be better.
Yeah, but we'll have to understand it. How many jumps we have to make.
I think more than code, what is the technique? If we understand that, then code
yeah.
That's more enough.
I kind of implemented that.
You have?
Yeah, sure. Definitely.
Is Dilip, right?
Yeah.
Yeah, Dilip.
Yeah. So you want to share it?
Yeah, I'm sharing that.
Okay.
So, yeah, so
you can go to the solution only, diagram, that it will be better.
Yeah. Okay.
Yeah, this one.
So what I'm trying to do is, so first I'll start from first element, so after in the final resultant array, the position of 1 has to be shifted to 3 positions on the right side, right? So first I try to shift that, but I'm not going to lose the value in that position at I plus 3. So I'm going to take that as a previous, store that in a variable, and next try to see where that element has to go. So that goes to 3 has to go to plus 3. It has to go to 5, right? Okay. This example is 2. Okay. So 3 has to go to 5. So it goes to 5. Now let's see how where the 5 has to go. Then 5 has to shift to 2 positions to the right. So it has to go to 0th position. So now every time we will check whether we reach the starting position. We started from 0. We went to 2, then 4, then we again came to 0. So it's kind of a cycle. It is shift. So we have replaced all these 3 elements as the correct positions in the final after final shift. Then when we are doing this, we try to maintain a count so that we will know whether we already shifted all the elements or less than that. So that if suppose sometimes the cycle may shift all the elements and so in that case, we can stop the iteration over there. So, but in this case, there were 2 cycles. First one was between 1, 3, and 5, and the second one was between this 2, 4, and 6. It can be more cycles too, but what the intuition is, we just try to take the first element and move on until we reach the same position. Then go to the next position and try to see try to see again until we reach the next position. So that's we repeat this until the count becomes the length of the array.
So in this array only we'll have 2 cycles, or it can be more than 2 cycles also.
Yeah, it can be more than 2 cycles. It can.
The cycles depend on the k, right? K is equal
Yeah,
to
yeah. It depends on the k. If the k equal to 1, then we get
One
cycle.
This is also an easy solution then. Yeah.
Yeah, it is.
Can you go through the code?
Yeah. Okay. So I just took the length and k mod n, so that if the k value is greater than length, that's then it read on each elements. With each elements, first I will take index. It's like a temp index, so that when I move on the cycle, in the previous elements, we need a value to replace in the next position. Then this while loop breaks when we reach the same position. Like in the first cycle, when we reach the 0th position, this while loop ends in that position. So first we try to replace 1 with 3. So our previous was 1. This position gives us 3. So we are going to with 1.
I think let me mute it.
Yeah.
Go ahead.
Yeah.
You unmute yourself.
Yeah, Dilip, can you unmute yourself?
Yeah. So then first in the first line we moved our 1 to 3 and stored this value 3 in the previous. Then we move our next pointer to this 3 location. And every time I do that, I maintain a count, so that I get to know when I moved all the elements to the right position. So then I 3 to 5 and 5 to 1. At that point, my next is equal to next is also 0 and index is also 0. So I kind of came back to the same position.
Yeah.
So I break the loop and check if the count is equal to n.
Okay. So in this one, I have a question. Like when you are saying the while loop, you are doing an infinite while loop, like while true, right? Instead of that, you could have said while next is equal to idx, right? Means instead of while, you could have used a do while loop there.
Next is not equal to idx.
Yeah.
And why do we have that for loop from up to the length of the num instead of k?
So it has to be num. Right?
No. It can be. I don't know. Like it can. If we divide the array,
we have to rotate only k times, so it should be. I think it should be k times only.
Yeah. Maybe it works until k times, because at max we can have k cycles. Like depending on the length, we can have k cycles.
Yeah. In that case, you don't need that last if block, right?
Yeah.
So can you show me the solution? So
Yeah. You drag this one up. No.
Just
drag
go
it
down
up.
a little bit. Yeah.
Yeah.
So here also, okay. Count is less than n. Yeah, they are also going up to the array length, right? Count is less than n.
Good.
Yeah. Even he was.
Can you look for the Java version?
I'm not sure why they are going up to the n.
Yeah, they are going up to the n. That's fine, but actually they are filtering it inside, right?
Oh, but why do we need to run that outer loop n times?
So if you see the count plus, that actually is fine. If the count actually is greater than the number of see, because if you say start is equal to 0, count is less than numbers of length. He's using the condition there, right? So he's not he is not going all of them. So he is only looking for the count value on line 14. And if you look at line 5, the condition where he terminates the for loop. He is not going through all of them. Because your count will increase, right? When you have done in a do while loop, the count will increase by more than 1.
No, the whole array needs to be shifted. So here, like the whole array needs to be processed at least once. All the element has to move at least once.
No, that's why the while loop is doing that.
Yeah,
but that's for checking cycle while loop.
So the while loop is actually moving the elements. So we just need to care about the first k element only.
I'm not sure whether it's
it might work also because, but there might be some corner cases and therefore they are using this count.
Yeah. So if we see this example, then this one finishes in one cycle only. Like in the first example, if we try to shift that, then even though k equal to 3.
So 1 to 4 you will go, right? Or 3 you will go.
So it will go one will go at 4 and 4 will go at 7.
7.
And then
7
7
will go
3.
at 3. And 3 will go at 6. And 6 will go at 2.
Okay.
Yeah, and 2 will go to 5.
Mm-hmm.
So cycle doesn't depend on the value of k, right? I mean,
yeah, now I got
like three value k equal to 3. That doesn't mean 3 cycles will have.
It won't be equal to k, but definitely it will be equal or less than k, I think.
It's slightly more than, but yeah, but not like you have to traverse all of them. That is true.
Yeah, yeah.
Maybe we can do sys out and see how many times it did.
Yeah, you can paste that code. I think there only you can run in the solution also.
Which one?
Go to Java, copy it. That here.
You can do in Python also, no?
Your Python also. Print you can use.
Okay.
Go ahead. Go if you have copy. Okay. I think 2 codes.
Sorry?
I mean, two times. Yeah. I mean, 2 times why you have this. You remove one, dep rotate. The other one, yeah. Which one
I
is
just changed the name.
Root one, rotate one. Yeah. Okay.
Okay.
Yeah. So
now,
what should I print? Should I
drag it up?
Print the n.
Print, huh?
Count. Print count. Yeah, count. N will be constant.
N length will be and
count change. Okay. So
yeah, it will just show the number of time. Now we know the k, right? In this case, k is
0.
For this only one cycle, so we got only 1 0.
But I think.
Let me check the k value and see as an example. Still 1.
Okay, so it's doing in one count.
Yeah.
So what Praveen is saying is it makes sense. Yeah. Maybe we don't even need the first while loop,
the
right?
maximum will be the mod of k and the number of array. That would be the maximum number of, like, that would be the number of times we'll be rotating, going into that loop.
I mean, n is equal to k, you are saying?
No, the array size, how many times we run this while loop at line 7, that would be the modulo of the array size and k.
Okay.
Array size and k. Okay.
Yeah, because every time you are hopping, right? K number of times. So that
yeah. So when you do k equal to 3 and the array size was 7, so it is
1 time.
We executed once. When you change to 2, we still executed once because the modulo is 1.
But is it modulo or it should be division?
It should be
n divided by k or modulo. Modulo maybe something like if you have 26 and then you're doing 10, so it will be 10, right?
Yeah, look at this.
6.
Yeah. If you do say 5, then you would do 2. K equal to 5.
Equal to 5, okay.
K is equal to 5, then it may be more than 2.
2 it will be.
2.
Huh? 0.
I think the count value what we are printing.
Because the exit is when you actually you looping in an infinite loop until you actually reach the same index where you started.
Oh, you put a break after print, I think. No, but at each step. No, every time.
This loop goes for 1 cycle. If you have more cycles, then we need to loop into like that many cycles. So number of prints has to be number of cycles.
Yeah.
Yeah.
If your num size is bigger and you have k is equal to 5, so nums should be like about 10-15, then you will get count more than that.
But isn't the solution example had 2 loops? The example that we saw in the solution. Shouldn't it print the count as 2 or no?
But example is different. So let me try.
It is almost same.
No, 7 is not there.
Okay, but here it should be again lesser in that case.
Let's see.
Oh, wow.
Yeah.
That's a good catch.
Yeah.
It's not consistent. I mean, is there any formula to come up with this?
Because when he increased the array size and still k was the smaller one, so it will you take only one iteration, right? So that made sense. Here k is equal to 2, so therefore it is jumping 1, 2, 3. Okay, no, I'm confused there.
Well, picking. Yeah, they have given some proof for this. I mean, you have to go through.
Yeah, we'll have to play with that. Yeah, they're saying something n by k, yeah, something like that.
Exactly. Those k into n by k.
Oh, that's the big theory behind it.
But if you get it, I think it would be the simplest approach. I mean, but we need to remember it. I mean, all of us. It's not that intuitive just by looking at this.
Right, but I know this one is important because it can be used in different places. This implementation, the reverse way is fine, is very specific to this app what you say problem statement, but the way it is flipping, moving all around the place by the cyclic way, this trick we can use at other places also.
Graph kind of like notes there.
No, I've seen it somewhere. I don't recollect it.
Okay.
But I think we might have, like yesterday what we were discussing about those postfix and prefix.
Infix, suffix. Yeah.
So this thing also is important. We should actually understand it properly and see. Okay.
Yeah, sure.
Maybe we'll go through it at some time. We can, or maybe post it on Slack if you have some inputs.
No, definitely.
Okay.
No.
Yep.
Yeah, I did intuitively, like, made a copy of that array and then shifted into that new array. So the next solution, if you go solution, and then the approach below this approach.
The reverse one? No, go down.
Using extra array.
Okay.
Yeah, so that will be extra size, right?
Yeah.
You want to share it, Darshan?
I have to log into my computer,
okay.
But it's the same. Like if you go to Java,
okay,
it's the same thing that I did.
Okay. So in that case, you are just copying the first k values into the other side, right? And then you are copying the other ones. But this solution is also okay in an interview, right? Because it's O of n. The time complexity is O of n. Only the space is there.
Yeah, space is more.
Yeah, space.
So this should also work. Yep. Okay.
Okay.
Yep. Thank you.
I think
stop the recording.